Alright, so today we start a brand new chapter in engineering mechanics. In fact, a brand new section. So today we're going to be learning on something called dynamics. So we have settled statics. All the lectures in statics is done. You are going to be applying dynamics now. So in statics, we learn about everything in statics which is not moving or motion but under constant velocity. So in dynamics, we will be learning all about motion. So basically, if you look at engineering mechanics, the branch itself consists of two things: solid mechanics and also fluid mechanics. So under fluid mechanics, there are a lot of branches. You have statics and dynamics, you have kinematics, but we are learning here lah. We are learning solid mechanics, and under solid mechanics, we are learning mechanics of deformable bodies. This one you learn strength of materials, yeah, this subject. Or this one. This is the one that you are learning right now. Mechanics of rigid bodies. Under mechanics of rigid bodies, or known as engineering mechanics, you learn about statics. Done. Currently, you are learning about dynamics. So under dynamics itself, there are two parts: kinematics and also kinetics. Kinematics deals with properties of motion, displacement, velocity, acceleration, time, but no force. Kinetics, you deal with all these things but additional force. So when you learn kinetics, you want to know what is driving the motion. When you learn kinematics, you want to learn what is the description of the motion. So this is the thing that you are learning right now. So pretty much we have covered 50% now, which is statics. So let's look at dynamics. So mechanics is the study of motion of bodies subjected to forces. So under statics, you learn about things like equilibrium of a body, whether it is at rest or moving at a constant velocity. So under dynamics, you deal with something called acceleration. You deal with A, which comes from Newton's second law, which is equal to F is equal to ma. So under dynamics, you have kinematics, which you have studied in the previous page. You only study geometric aspect, geometry only. So you learn about displacement, which is in meter, velocity is probably in meter per second, acceleration will be meter per second squared, and also angular, things like theta, theta dot, theta double dot, or theta, omega, and alpha. Theta stands for angular displacement. Omega stands for angular velocity. Alpha stands for angular acceleration. Then you've got kinetics. Kinetics, we'll be learning this in the next chapter. So you study on the forces which is driving the motion. So things like force, moments, torque, momentum, impulse. We're going to be learning all this. So this is the difference between kinematics and kinetics just now, which has been explained. So under kinematics, there are a lot of motion. So we'll be learning something called linear motion, motion in a straight line, curvilinear motion, and also relative motion. So under this, there are a lot of coordinate systems lah. But the only thing that we'll be covering is on XY coordinate system. Most likely we will not be covering this one, and we're not covering this one. Only XY coordinate system. So let's look at certain derivation. When you are looking at properties of motion, you have something called displacement. So it's basically this is final, right? Final location minus original. So you have an S lah, which is, I guess the unit is meter. Velocity is when you compare the displacement and you divide by time. So displacement divide by time, you're going to get velocity. In terms of the derivative, it can be something called ds over dt. So you're going to get v. And next will be acceleration. When you find out what is the final velocity minus by original velocity, then you're going to find out what is the acceleration. In terms of derivative, it is dv over dt. So these are certain depiction of particles moving. So when you have a change in velocity, yeah, probably say something like that, change in velocity. So this one would be change in displacement. Yeah, change in displacement. Displacement has been changed, you have velocity over time. So okay, so once you've got all those things, you can also integrate back. For example, dv over dt is equal to a. You can integrate, bring this over here, dt bring over here, you're going to get dv is equal to a dt. So integrate both sides. So this one will be original v to final v, original time to final time. So if you integrate, you're gonna expand the thing. So you have to plug in, right? This one, dv, you're gonna get v lah. V naught to v is equal to a. If a is constant, you're gonna get a t naught over t. So if you expand this one, you're gonna get something like this lah. V minus v naught is equal to a t minus t naught. So you're gonna get something like this equation. If your t naught is equal to 0, which almost all the time t naught is equal to 0. This one is gone, you're gonna bring this one over there, you get this equation. So among the equation which is important is this one lah. So this one works if you have a constant acceleration. For constant acceleration. So this is based on probably from this no, from this one. From this you can integrate and you can derive this equation But if this equation can be even more simplified if it has constant acceleration. So yeah, this is how you derive it. But you don't need to remember how to derive it lah. We are applying the formula only, but the derivation is very simple lah. Okay, next. From the previous equation, now we're looking at this one. From ds over dt is equal to v. Now dt bring over here. So you're going to get dt. You're going to get ds is equal to v dt. You can integrate. So this is what we're doing right now. From this one, bring dt over here. You're going to get ds is equal to v dt. Integrate both sides. S naught to S. This one T naught to T. So this one, if you expand it, you're going to get S minus S naught car is equal to oh, I think we have to plug in some. Plug in this one. Plug in this one over here. V naught plus AT dt. This one is done. This part is done. This one you have to integrate one more time, right? This one. Integrate from T naught to T. If you integrate this one, you're going to derive this equation. So this equation is very important. We're going to give it a name. This one is equation number 1. This equation, we're going to give it a name. This one is equation number 2. And finally, this one, we are going to call this one equation number 3. So equation number 3 comes from this. So this one has to come from these two things lah, which is dv over dt is equal to a. So dt is equivalent to dv over a car. Okay, let's take this one. dv over a. And then take a look at this one, the second one. ds over dt is equal to v. So again, rearrange it. dt is equal to ds over v. So dt, okay, look at dt. dt same with this one. So you can equate them both. dv over a is equal to ds over v. So bring this one here, bring this one forward. You're going to get v dv is equal to a ds. So from this one, we can integrate once again, and we're going to get the third equation. I think all these equations you have learned before in physics. When you deal with motions, yeah, you learned before in physics, probably in Form 4. Last time, I think they're going to give a different name code. Probably they give you V is equal to U plus AT code, probably something like that. Yeah, something like that. This one, last time in physics, you don't learn S naught lah. You just learn S is equal to this part only. But for now, you have initial condition and such. So you have things like this lah. You have S naught. S naught refers to initial. All the knots refers to initial. Oh, this one also, initial. So if this one is initial, the other one would be final. This one is final. Not, it's a good reminder that this is initial. Okay, so what's the conclusion here? The conclusion is that we got to remember these three formulas. This formula, and this formula. You have to remember them. If you don't remember them, you have to derive on your own. So better you remember. Or you just look at the last page where all the formulas are given to you. Okay, so as a summary, you have displacement. If you want to find velocity, you can differentiate. So you can differentiate displacement, you're going to get velocity. If you differentiate again, you're going to get acceleration. And if you were to do it reversely, if you have data in terms of acceleration, for example, the data is a is equal to 3 t squared. This is a mathematical expression lah. If you have this data, you want to find out what is the velocity, you have to integrate. And then if you have data, for example, v is equal to 2t squared plus 5t. This is the data for v. You want to find out what is displacement. In order to do that, integrate one more time. So, yeah. Differentiate this route. Integrate is going the upper route. Okay? So look back at your notes. So now it's time for you to do some exercise. So this is the data that you get. This is important lah. This is the mathematical expression. So this car moves in a straight line. Velocity is this one. When so time is in second, and when t is equal to 0, s is equal to 0. So the initial condition is when t naught is equal to 0, displacement is also 0, meaning originally the car is from here lah. It travels. Find the position when t is equal to 3 seconds. So obviously when you look at this is a mathematical equation. This mathematical equation is something that you can plot. For example, if you were to plot v over t. So how does the graph look like? You got to plug in lah. If you plug in when time is equal to 0, this one becomes 0 lah. The whole thing is 0 lah. If you plug in when time is equal to 1, jadi berapa? 3 campur 2. Betul lah. Katalah time sama dengan 1. You're gonna get, yeah, the velocity will be 5 lah. So 1 velocity jadi 5. Kalau letak t sama dengan 2 pula. So 3 lepas tu 2 kuasa 2 campur 2 kuasa 2. So what do you get? 3 multiplied by 4 plus 2 multiplied by 4. 12 campur 8. 20 meter per second. So at 2 seconds, it jumped already. From original here, 5, 10, 15, 20. 20 is here It jumped to here. So if you were to plot this graph, it's going to be exponential like that. So this graph is the graph of v is equal to 3t squared plus 2t squared. So if you were to find the position when t is equal to 3 seconds, you need to do a lot of things lah, and plot the whole thing. So when you are doing this, your resolution is very bad lah. You're doing it at 1. How about the data that you have when it is at 0.5 or 1.5 or 2.25. You don't have all this data. So we don't do it like this. We just use data from either this one, data from integration or differentiation. So this is the one that you should be looking at. Differentiate or integrate. So look at your data. Your data is V is equal to 3t squared. So where are you? You are here. V is equal to 3t squared plus 2t squared. 2t squared. So you are here. So you are here. In order to get displacement, where do you want to go? You want to go back to S. In order to go back to S, you need to integrate. So that's what you should do. So now we don't do this method. We need to do this method. Let me remove this and clear your minds. So let's list down your mathematical equation. Mathematical equation would be, is there a quicker way for me to do this? Screen, I cannot clear. Never mind lah. Okay, V is equal to 3t squared plus 2t squared. Find the position. So you know already lah. What do you know? You know that ds over dt is equivalent to V. This is what you know lah. Differentiate S, you're going to get V. So bring this over there. You're going to get ds is equal to V dt. So plug it in. V is equal to 3t squared campur 2t squared dt ds. So what do? We integrate. Originally time is equal to 0, final time is 3 seconds. So you plug in lah. Originally 0, final is 3. Original displacement is 0, final displacement is unknown. So when you do integration, there has to be one unknown. This is the thing that you are trying to find out, which is S. So let's proceed doing the integration. So integrate ds, you're going to get S. And you are going to evaluate it from 0 until S. Integrate ds, you get S. This side, there's a difference, right, between integration and differentiation. So you need to remember So 3t squared, 3t kuasa 3 per 3 kot, plus 2t kuasa 3 per 3. So this one you have to evaluate from 0 until 3. So this side you're going to get S minus S naught. Okay. S minus S naught this side. And how about this side? Settle. Dapat T cube plus 2 over 3 T cube. Still not being evaluated yet. So we got to plug in lah. S minus S naught. Originally is equal to 0 lah. Displacement is 0 lah. S naught is dislocation, so there's no displacement yet. So S is equivalent to, you got to plug in already lah, 3 cube plus 2 over third 3 cube. Berapa? Use your own calculator. Mode 1. 3 kali 3 kali 3 3 cube 27. 27 plus 27 kali 2 bagi 3. Berapa dapat 18. So this is the displacement lah. 27 plus 18. What do you get? 45 meter. This is the displacement. Equal to, what is the value just now? 3t squared plus 2t squared. 3t squared plus 2t squared. So this is V. We're trying to find acceleration. So if you don't remember, you can draw this one as VA. You are here, just now you are trying to find displacement, you integrate. If it's this side, you're going to have to differentiate. If you're trying to go here, you need to differentiate. So V is equal to this value. You need to do this one, dV over dt. So dV over dt, differentiate. So what do you do? I think it is 60 plus 40. And then you need to evaluate. What is the answer again? What is the question again? Determine the acceleration when time is equal to 3 seconds. Acceleration at time is equal to 3 seconds. So now you got to plug in lah. dV over dt, you get acceleration already. 6, plug in your 3 plus 4, plug in also. So this one becomes 18 plus 12. So what do you get? 18 plus 12. 40 kah? 30. 18 plus 12. Yeah, 30. What is the unit? Meter per second squared. What was the previous unit? This is meter, correct lah. So this is how you look at particles. So this is a car. It's basically a particle. Alright, so this is a car modeled as a particle, and the particle is defined by a mathematical equation, which is this one. And by knowing a mathematical equation, you can find out a few key things, which is position and also acceleration. So that is the thing that you need to understand. So it's not very hard. So basically you gotta understand. You need to understand this one. You need to understand where you are. This is where you are. Where are you trying to go? You're trying to go and find out which information. So this one, yeah, integrate or differentiate. Okay, next. Alright, so we have done some exercises. So we've done few examples. For example, this one. So far, we've been dealing with things like displacement, So this is displacement, this is velocity, this is acceleration. All these can be represented mathematically. In terms of an equation. So if you see, so far we did one example, and this example you see that V is equal to these things. So this V is actually the function of t. So you can have S as a function of t, you can have V as a function of time, and you can have acceleration as a function of time. So when you're dealing with S, V, or A as a function of time, you have to settle this one lah. You can either differentiate or integrate to get the answer, like what we did just now. So let's do one more example. This again, you have a V as a function of time lah. So you have A, S, you have V, you have A. Again, this is what you are, where you are right now. 5t squared minus t cubed. If you want to determine the position, you have to go this way. You have to you have to go this way, right? You have to integrate. If you want to differentiate, if you want to get acceleration, you have to differentiate. So it depends where you are in this diagram lah. Where you are in this diagram. Okay. So this is one exercise that you should try on your own lah. Try on your own. The only thing which is a little weird is probably the initial condition lah. The initial condition is changed a bit. So when time is equal to 0, S is no longer is equal to 0. If you go up here, when time is equal to 0, S is equal to 0, right? So when you get something like this, your limit original displacement becomes 0. At the final condition, which is this one, this is the thing that you're trying to find. But in this case, when time is equal to 0, S already has a value. So probably let's look at it a bit. So you are here, you're trying to find the position. You need to integrate. So you know that let's do it here. ds over dt is equal to v. Bring this over here, you're gonna get ds is equal to v dt. So you gotta plug in this thing, 5 t squared minus t cubed dt is equal to ds. Now you gotta put your integration point. Put the integration point. ds, original displacement, is already has a value 6. When time is equal to 0, s is equal to 6. So you have to put 6 here. This one you have to put s. And this one, when time is equal, so this one is from original time, from 0 lah. So until 5 seconds. So this one, the limit will be 5 seconds. So this is what you do when you are trying to solve for displacement. So next, you can solve this one. And then acceleration. If you are here, you are going to acceleration, you need to differentiate lah. Which is, you know already that you're gonna get acceleration. So you are going to get acceleration by differentiating them. So dv over dt. So what do? You're gonna get dv over dt 5t. Yeah, the correct way to write this is like this, d 5t squared minus t cube dt. So differentiate this equation. So dapat berapa? 5 10t tolak 3t squared. This is your A, and then A evaluate when time is equal to 5 seconds. 10 plug in 5 minus 3 5 squared. So you get the value. So do this. So far we've done both cases, both equations is in the function. This is important. In the function of time. Alright, so next, if you look at this question, this is a small projectile. It is forced downward into a fluid medium. So this is the fluid. This was the original position of the projectile. It is fired down. Now the projectile is here. The initial velocity was 60 meters per second. Due to the resistance of the fluid in the projectile, experience a deceleration if equals to this one. So this is the acceleration, but in terms of deceleration, so it becomes a negative value. So now, let's determine the projectile's velocity and position. So if you look back, you have this one, S, V, and A. Now you are here. You have A, which is acceleration. You are trying to go up. So what do we do? If you're trying to go up, you have to integrate to get velocity, and you have to integrate the velocity function that you get in order to get displacement. Integrate one more time. So A is a function of negative 0.4 V cube. So V cube. So this is our mathematical model or mathematical equation. So you need to find out what is the projectile's velocity and position. So A sama dengan apa? So when you have things like this, A is now a function of velocity. So when something like this happens, probably you can use the previous equations. This one. There are 3 options for you to choose from. So this one is a function of time, this one is a function of time, this one you have dv and also ds. So let's check it out. So you might be able to use this one. V dv is equal to a ds, or dv over dt is equal to a. So which one is more suitable? You can test and try to find out. If you plug in here in VDV ADS, what do you get? VDV ADS. So let's try VDV equals negative 0.4 v cube ds. If you integrate both sides, you need to put in what are the initial condition. V naught is equal to original velocity 60. V final, you don't know, right? So this one is the S. Original S. Original would be 0. Final S. S final, you don't know. So you have two things that you don't know here. You don't know the velocity and you don't know the displacement also. And it's trying to let you know what is the position after 4 seconds. So you need to find velocity at 4 seconds and position at 4 seconds lah. Gini, what happened at 4 seconds, what happens at 4 seconds. There's no way that you can plug in time here. So no time. So maybe we cannot solve using this one. Maybe we need to do another way, yeah. So let's try to do it another way. Let's remove this one. Try another method. Maybe this one cannot be used. Maybe. Let's try another method. So, okay. Alright, so let's try the other method. Let's get back to this. Our acceleration is negative 0.4 v cube. We use this one. dv is equal to a dt. Where does this come from? It comes from here. dv over dt is equal to a. Being this over here, so you've got this. So plug in this one, negative 0.4 v cube dt over dv. So if you look here, you have v function. This one is v function. This one is t function. So this one you have to bring it over here. So if you bring it over here, you're going to get dv over negative 0.4 v cube is equal to dt. Something like this you can surely integrate. So you can integrate both sides. From t naught until t, from v naught until v. So what are the values? The values you have to refer to initial velocity, which is 60 meter per second. Initial velocity 60 meter per second. Final velocity we don't know. Okay, so final velocity we don't know. Initial time 0. Final time, this one, right? 4 seconds. So 4 seconds. So we solve this integration. We're gonna make it. So we gotta solve this integration. Let's simplify it a bit. Negative 0.4. 1 over 0.4. This is going to be, I gotta make space. So let's start over here. So negative 1 over 0.4 times dv over v cube is equal to t over here, which you need to evaluate from 0 until 4. 1 divided by 0.4, 2.5. So negative 2.5. This one you can simplify a bit, it becomes V kuasa negative 3 dV is equal to T, which needs to be evaluated from 0 till 4. So just integrate this one. Negative 2.5 V kuasa negative 3 plus 1 over negative 3 plus 1, right? Equals this one, T 0 until 4. So this one equals negative 2.5 V kuasa negative 2 over negative 2 equals this one lah, 4 to 0. So continue. So final equation becomes negative 2.5. Let's change to another color. Negative 2.5 over negative 2 V kuasa negative 2. This one you need to evaluate from where to where. This one original velocity 60, final velocity V you don't know. This one T evaluated from 0 until 4. 2.5 bahagi 2, 1.25. 1.25. This one is actually 1 over V squared minus 1 over 60 squared equals 4 lah, I suppose, if you plug it in. 4 minus 0 lah actually, right? So let's solve this. 4 divided by 1.25. This one equals 4 bahagi 1.25. 3.2. This one becomes I think this one is eliminated. It becomes too small. But let's check. 1 over V squared. 1 over V squared. I don't think we should put in values first. Let's leave it as T first. Simplify it a bit. Let's leave it as T. So T over 1.25. So 1 over V squared is equivalent to T over 1.25 plus 1 over 60 squared. How does this look like? Is it easier to solve? This one is 1 over V squared. Okay, now let's plug it in. 4 over 1.25 plus 1 over 60 squared. And then maybe we can solve. Another small area here. 4 bahagi 1.25. So 1 over V squared is equal to 3.2 plus 1 over 60 squared. 60 squared. X negative 1. 60 squared. It's too small. It's almost 0, close to 0. So V is equal to 1 over 3.2 square root. Yeah, let's try. 1 bagi 3.2 square root. You're going to get the value as 0.559. So the value is 0.559 meter per second. This is the value. Let's check the answers. Yeah, okay, 0.559. Okay, we're done. So next, this is the first part lah. The next part will be to find the position. So position, you can look at this one lah. You have to integrate one more time. These are the steps. It's too long, but you can refer to here. Probably final exam won't be this complicated. Well, this is something that you can refer to. Okay, next. So next is this one. This is a problem that you really have to understand. I'm gonna need to put one more page probably. Add one more page, blank new slide. Maybe 2 new slides. Because the calculation is kind of long. Okay, so yeah, you can take a break, pause if you want. This is a rocket. This rocket is traveling at 75 meter per second going up. So it's originally from here 0. So it flies away 40 meter. When it is 40 meter from the ground, the engine fails. Originally it has an engine. 40 meter above the ground, no engine. Engine gone, no engine. So it is traveling at the original velocity only. There is no additional power or additional drive or additional force driving the rocket going up. So determine the maximum height that is going to reach by the rocket and determine the speed just before it hits the ground at the floor here. So the rocket is traveling up, going up at plus 75 meter per second. For the entire motion, acceleration g is negative 9.81, which is going down 9.81. So in this case, you can use these formulas that we have derived before. Which formula? This formula. This formula number 1, formula number 2, and formula number 3. Why so? Because it's under constant acceleration, constant acceleration, constant acceleration. Which acceleration? Gravity, which is equivalent to negative 9.81 meter per second squared. So gravity. So it is, yeah, it works for this one lah. So number 1, we need to find the displacement. What equation can we use? We can use V is equal to V naught plus AT. Second equation, S is equal to S naught plus V naught T plus half AT squared. And final equation number 3, V squared is equal to V naught squared plus 2A S minus S naught. If you don't remember this yet, you can look at the handouts or your formulas. It's available there, or you can memorize this one. So these are the 3 equations which you can use for any motion under gravitational pull or constant acceleration. So you need to find what do they want to find? Maximum height. Maximum height means you need to find S lah. So you cannot use the first equation. The first equation does not have any S value. Second equation, yes, it has S. How about the third equation? Third equation, it has S. Yeah, it has S. So it's either number 2 or number 3. But for number 2, you need to find time. What is the time? Because why? In this equation, you have time. If you don't have time, you cannot solve it. So what is the time? You don't know yet. You are trying to go up maximum, but they never give you the time. So you cannot use second equation, you cannot use first equation, there's only third equation left. So you have to use the third equation. So how to do it? So let's try. Simplify it a bit. Constant acceleration. Let me clean up this question. So we have decided, after much consideration, we need to use equation number 3. Equation number 3. Original velocity. V squared. Let me choose a different color. Red color. V squared is equal to V naught squared plus 2a s minus s naught. V squared stands for final velocity. V naught stands for original. So what do you do now? Where is our original? We need to analyze from location A here. This is our original. Where is our final? Location B over here. This is our final. So if you to imagine, this rocket originally has some rockets, right? Suddenly it failed. No more engine. So no more engine. It is only traveling at 75 meters per second. So it travels. So 75 meters per second at this location. So let's say it travels here. Original velocity is 75 meters per second. So since it is traveling, going up, it is also slowing down due to gravitational acceleration or something called deceleration. Negative 9.81 meter per second every second. So every second it is slowing down by 9.81 meter per second. So let's say the position of the rocket here, let's say it travels 1 second. So velocity here becomes 75 minus 9.81. So berapa? 75 minus 9.81. 65.2 lah. Kurang 65.2 meter per second. Ini selepas apa? Selepas 1 second travel. 1 second. Let's say they travel lagi 1 more second. It travel 1 more second. So 1 second. So total dah jadi 2 second lah kan? Dah jadi 2 second. Where is the location of the rocket now? Let's say the rocket is here. What is the velocity at location here? Let's say this location is location 1. Kita dapatlah V1 kan? Let's say this location is location 2. What is V2? Very easy, right? So V2 equals, tadi berapa? 65.2 tolak 9.81. 65.2 tolak 9.81. Now you get 55.4. 55.4 meter per second. So V2 becomes 55.4 meter per second. So, do you get the trend? The trend is the rocket is slowing down. The rocket is slowing down, slowing down. So, just imagine you have a ball. You throw the ball up, throw the ball goes up. At one point, the ball will stop. Stop. Why does it stop? Because planet Earth has gravitational pull. So, since kita ada gravity, the ball stops lah. Kalau tak ada gravity, kamu baling objek, the object will just fly away non-stop. Okay? So, luckily we have gravity. It is slowing down because of this lah. Negative 9.81 meter per second. So, if you go to the moon, where do you go? Moon. So, dekat bulan, you have micro gravity. So the gravity at the moon is very low. But you still have some gravity, but it's very low. It's microgravity. So things in space behaves differently. So that's the thing lah. So my point is, so you can use the first equation. For example, first equation V is equal to V naught plus AT. Let's say you want to find out bila velocity jadi zero. Final velocity lah kan. Final velocity jadi zero. Okay, let's try to solve this. Maybe kita boleh tahu kot berapa time dia jadi zero. Final velocity jadi zero. Original velocity berapa? 75. Original velocity 75. Betul Plus gravitational pull negative 9.81. Time tak tahu. Boleh cari So equation becomes 9.81 T equals 75. So T sama dengan 75 bahagi 9.81. 7.645. So 7.65. 7.65 seconds. Oh, so equation number 1 pun you boleh guna juga. In 7.65 seconds, this rocket will be at the maximum altitude. Okay, maximum altitude. So equation number 1 boleh guna. Equation number 2, kalau cuba plug in time kat sini, plug in the time here, I think you're gonna get lah berapa displacement. Or you can simply use equation number 3, like what we are doing right now. So I'm gonna rub this off. Make sure you write in your notebook. Let's try equation number 3. Final velocity, bila dia dekat maximum, final velocity will be 0. Original velocity, which was 75 squared plus 2 kali negative 9.81. Negative 9.81. Original displacement. Ini final kan? Rub this off. Oops. 75 squared to negative 1. Ini adalah final. Final displacement you don't know. Original displacement, what is it? Kamu dah terbang 40 meter kan? So dah tahulah. You have fly away 40 meter. So, berapa? Boleh settle tak? 75 squared. 75 squared. 5625. 5, 6, 2, 5. S minus 40, don't know this one, plus 9.81 kali 2, 19.62. 19.62. But this one is a negative, careful. Kali dengan S tolak 40. 7.65 second, let me write down here. Time maximum 7.65 second. I'm gonna rub this off. Ini kosong, kosong. Ini negative. So you have to multiply properly. Slowly do your mathematics. Kali dalam ni, and then multiply again with this one. So 5, 6, 2, 5 minus 19.62 S campur 19.62 kali 40, 784.8. 784.8. Can you solve this? So bring this one over there, right? So you got 19.62 S sama dengan campur 5625, 5625, 6409.8, 6409.8. So kira punya kira S sama dengan berapa? Divide by 19.62. So dapat 326.7 meter. Okay, so I'm gonna rub some of the masses here. Where can I rub? This one I can take out. Take out all this nonsense. Okay, now we are cleared. So where are we right now? We are... Dia dah terbang 40 meter. 40 meter. That's why you have this 40, okay? Look at this 40. See, this 40 is being represented here. Original displacement. So this maximum altitude that the rocket will go, this one lah, this one. This maximum altitude is actually 326.7 meter. That is the displacement of the rocket going up. So now you can check lah, what is the actual value. So the actual value, the answer is so short. You can check here. 327. Betul lah tu, 326.7. So that's why you have to listen to videos, attend lectures. Otherwise, how are you going to understand all this? It's very hard to understand by looking at these two steps. Okay, so what else? So number 1 settle lah. Number 1 done. Determine the speed just before it hits the ground. See, you have one more thing that you can do if you want. Just now we checked that the time at the height here is actually 7.65 seconds, right? You can check it with equation number 2. Let's do that. Let's check with equation number 2. So let's plug in here. What is the equation? Let's plug in the equation. 7.65 second. Okay. Equation number 2. Just now we checked. It should be 7.65 seconds to go maximum. This is where the rocket originally at. We just calculated that it would take 7.65 seconds. Should it be the same? It should be. So S is equal to S naught plus V naught T plus half A T squared. S tak tahu, original displacement 40 meter above the ground, remember? Already 40 meter. Original velocity kali dengan time. Original velocity berapa? 75. Time 7.65 plus half negative 9.81 7.65 squared. Let's see, did we get it correct? 75 times 7.65. 573.8. 573.8. Ini akan jadi negatif lah. Negatif. 7.65 squared kali 9.81 bahagi 2. 287. 287.1. So ini dapat S. Cuba kira berapa? 40 campur 573.8 minus 287.1. Yeah, exactly. You're gonna get 326.7 meter. Exactly. So obviously you can use all equations lah. If it's for if it's for motion with constant acceleration. Okay. Did we solve everything? We haven't solved the speed just before it hits the ground. So, dia terbang. Sekarang dia kat sini. Kamu nak analyse dia turun bawah. Just now kita analyse A kepada B. Just now. From here up until here. Now kita nak analyse B to C. So which formula should we use? Do we know the time? Do we know the time? No. 7.65 is from 40 meter ni. From above until down, we don't know. I guess if you don't know the time, use equation number 3. Don't know the time. So what do? Use equation 3. Very easy. V squared is equal to V naught squared plus 2A S minus S naught. Something very high. What is the speed originally? V naught is equal to, what is it? What is the speed originally? At above, you guessed it, right? It stopped. So original velocity is 0 meter per second. Final velocity It should say final what? It should say final velocity just before impact, right? Because after it impacted, the final velocity will be 0 lah. But we need to find out what is the final velocity just before impact. So that would be, the thing that you need to find out. Distance kita tahu 326.7 meter. This is the distance. So let's solve it using this equation over here. So this is the one that you're trying to find lah. V squared final. Original velocity 0. 2 negative 9.81. S ni apa dia? Final displacement. Final duduk kat sini lah. Final duduk kat sini. S not duduk sini. S tak tahu. Betul ke? Tahu S would be 0. Kita ambil datum kat bawah. What's a datum? Datum is a reference. So final displacement is 0. Original height dia adalah 326.7. So let's try. This one becomes 0. Ini jadi berapa? 2 kali 9.81. It becomes a positive lah. 2 kali 9.81 kali 326.7 square root. So you're going to get velocity is equal to 80.06 meter per second. Okay. This equation has been simplified. V squared is equal to V naught squared plus 2A S minus S naught. Ini simplified. So you might wonder why this is 0. Why this is 0? It's easier to take a datum reference as 0. So ground is 0. We take positive going up, displacement as positive. So since final location is on the floor, so this is final, right? This is final displacement. Since it's on the floor, put it as 0 lah. That's why we get a negative value and dia jadi positive balik. And final dapat 80 meter per second. So let's check it out. Total jawapan. Yeah, it's actually negative 80.1. Depends on how you calculate. 80.1 meter per second. Okay. So, what is important for you to know? The important thing is I'm going to need to add one more page. Oh, what is this? Screen, white screen. The important thing is like this. You have a ball. It goes up. Maximum height. Let's say ball ni originally ada velocity kan? Berapa tadi? Bukan ball, rocket. 75 meter per second. It goes up. As it goes up, velocity becomes slower, right? Velocity becomes slower. Why? Due to negative g. Negative g kah? A is equal to negative 9.81 meter per second. Becomes slower. At maximum height, velocity jadi 0 terus. velocity becomes 0. As it goes down, it accelerates a bit. Goes down, accelerate. Goes down, accelerate. So velocity increase. Okay, velocity increases. Since the vector of the velocity is in the direction of 9.81, so velocity becomes increase, increase, increase lah. So you can calculate velocity easily. Okay, so now we can do 2 more exercises. This one looks pretty simple. Okay, let's get back to this.